Evening folks, and welcome to this demonstration of my Bulova Accutron watch from 1976. Now this watch has a tuning fork movement, which is an electrical powered movement that kind of bridged the gap between mechanical watches and later quartz watches. So most timepieces rely on an oscillator of some sort to regulate the timing of the watch, and on a mechanical watch the oscillator is a balance wheel, which is a small metal wheel with a spring inside it, and it rotates backwards and forwards, typically either 4 or 8 times a second, and that directly mechanically drives the movement of the hands. Now in a quartz watch you've got a quartz crystal is what's oscillating, and that typically oscillates 32,000 times a second, and that is actually electronically counted, the pulses of that, which then uses a motor to actually drive the hands of the watch. And the faster you oscillate, the more accurate the potential for the watch is. Atomic clocks use oscillators. They use a thing called a cesium fountain, which is oscillates at an extremely high frequency, and it's just a bunch of cesium atoms being excited. Anyway, a tuning fork watch uses a metal tuning fork inside the watch, powered by electromagnets, but it does still mechanically drive the hands. And the tuning fork runs at about 300 times a second that oscillates, and the same movement was used in Omegas for quite a few years in the 60s and 70s, and they were labelled F300 because that was the frequency at which they oscillated. And because at the time these tuning fork watches were far and away the most accurate timepieces available, certainly portable ones, they were used on the Apollo missions for the panel clocks in the command module. Obviously the astronauts had their Omega Speedmasters on their suits, but for most main mission events they used the clock, which was powered by a Bulova Accutron movement, except on Apollo 13 when they had to turn all the power off, and they still use their Speedmaster for the engine burns. So how does it work? Well, I've taken the back off this one to show you. These are the top 2 tines of the tuning fork, and it's a sort of V shape down to the bottom there, and within these ends you can see the electromagnetic coils which provide the power to keep it vibrating, but it's the size and shape of it which sets the frequency at which it vibrates. Underneath this bridge plate, one arm of the tuning fork has got these 2 tiny little arms on it with jewels on the end, and they actually drive the movement of the index wheel. And because it vibrates at such a high frequency compared to a normal mechanical watch, this index wheel, which is less than half the size of the battery, needs 320 teeth on it. And with such a small wheel with so many teeth, you can't actually make them out with the naked eye. You need a microscope to see the teeth. They're about 10 microns deep. And similarly, the coils that drive the tuning forks up here have got 8,000 winds of wire on them. Believe it or not, you won't be able to see that with the camera really. But yeah, an incredible level of accuracy considering these were first available in 1960. So the 2 characteristics of these tuning fork watches, one of which I can show you, and they're maybe not so easy. The first one is the extremely smooth sweep of the second hand there. And if you compare this to a mechanical watch, you can just about make out that is actually ticking there, and it's moving. I think this one's 8 times a second. It's an ETA 2824 movement inside. But you can make out the fact that it is moving in increments, whereas this, it's moving 300 times a second. You're not going to make that out. And the other characteristic is, which I'm going to try and show you, but you might have to turn the volume up to hear it, is the noise it makes. So obviously a quartz watch doesn't make any noise. A mechanical watch, you can hear ticking away, and a tuning fork watch, or hummer as they're sometimes called by watch specialists, actually make a humming noise. So I'm going to put this face down on the table, and I'm hoping if I'm very quiet you can hear the noise it's making. So I hope you can hear that. It's a sort of noise, and that's why they call them hummers. Anyway, I hope you've enjoyed this video, and I'll see you again soon. Cheerio!